Okay, so factoring is what we're talking about today. So with factoring, this is kind of a flow chart to help you with this. So you start with the GCF. It's the largest number that divides into every term evenly, or the smallest exponent on the variable that's in each term. And then once you want to always look for that first, okay? That's always your first step. Then what you do next depends on how many terms you have. So if you have two terms, you're either going to do a difference of squares formula, or you're going to do sum or difference of cubes. We are not going to go over the sum or difference of cubes. You can Google that if you want to, but we're not going to go over it. If it's three terms, you have kind of two cases, although you can do the same thing for both of them. If you have a leading coefficient that's 1, LC is leading coefficient. If your leading coefficient is 1, you're just doing basic factoring. You're looking for two numbers that multiply to the last number and add to the middle number. If your leading coefficient is not 1, that's where it gets a little weird. Some people teach guess and check. Some people teach a weird method. We had one at my old school that was called slip and slide. Some people teach it like I do. So I teach a specific method. It takes a little bit longer than some other methods, but I like it better. So I call it maybe split the middle and then factor by grouping. I'll show you it, but if you have a method that works, use it. All right, you don't have to use my method. I don't care. But you need to know how to factor something that has a leading coefficient that's not 1. That is going to be important because a lot of people who struggle with calculus struggle because they don't know how to factor. All right, and then if your polynomial has 4 terms and it can be factored, you would typically factor by grouping, or you might have to do some synthetic division and then factor it. It just kind of depends. We're going to look at factor by grouping, but it is possible that you might not be able to, or you might have to do synthetic division. All right, so we're going to look at a couple of examples real quick. So first thing we want to do when we look at this is look for a GCF, and there is one. 3 divides evenly into both of those, so we're going to go ahead and factor out a 3, or divide it out, and get x squared y squared minus 9. That is 2 terms, so then we're looking for difference of squares or possibly sum or difference of cubes. These are perfect squares. 9 is a perfect square. It is a difference. There is no sum of cubes or sum of squares formula, so please don't do it. Difference of squares, you take the square root of the first part, the square root of the second part, and it's always 1 plus 1 minus, and the order doesn't matter. Okay? So that's difference of squares. You should hopefully already know how to do that. We're going to do a 4 term because you got to know factor by grouping to do this method. So we're going to review factor by grouping. So that's 2x cubed minus 4x squared plus 3x minus 6. So factor by grouping works by grouping the first 2 terms together and the second 2 terms together. Second group, whatever, last 2 terms. We look for the GCF in the first 2 terms. So 2 divides out of both 2 and 4. And the smallest power of x that's in both terms is x squared. So that's our GCF. We factor it out. If we take a 2x squared out of this, we get x. If we take a 2x squared out of this, we get 2 left over. All the x's go away. Then we do the same thing with the last 2 terms. We look for a GCF there. The GCF of those is 3. And then when we divide it out, we get x minus 2. These 2 should be the same. If they aren't, then you can't factor by grouping, because the next step is to think of this term, this as a term, and this as a term. They are technically. They're separated by addition. They have a GCF. It's x minus 2. So we're going to factor out x minus 2. And what we're left with from this term is 2x squared. And what we're left with from this term is 3. By the way, if this term is negative, you do need to factor out a negative here. All right, so that's as far as we can go. If this were a difference of squares, we could factor it further. So it is possible to keep going with these 4-term ones, but that's good enough. Okay, real quickly, I want to do some pretty basic factoring ones just as a reminder. Oops, there should be an X there. Okay, so this has 3 terms. There's not a GCF, so we don't need that. 3 terms, leading coefficient of 1. This is easy factoring. We don't have to do some special process. You know, x times x gets you x squared. And then we want to look at factors of 48 that add to 14. And it's positive 48, so we know they're both going to be negative or both going to be positive, and positive 14, so they're both going to be plus. All right, so we could put the signs in right there. So you have to think about what multiplies to a positive and adds to a positive. Factors of 48, I always list them. You may know what it is right off the bat. I don't know, but 1 times 48 is 48. 2 times 24, 3 times 16, 4 times 12, 6 times 8 is 48. The ones that add to 14 are 6 and 8, so we just fill them in. And which one goes where doesn't matter. All right, so that's your basic factoring. I'm going to do one more because, oops, that's not plus. That for whatever reason, this tends to throw people for a loop when you have two variables. So we have two variables, x squared and then a y squared at the end. As long as it's set up like this with the x squared and the y squared, you can factor it. It's not a big deal. And again, it's a leading coefficient of 1, so we can just jump right into factoring it. X times x is x squared. Y times y is y squared, and then we need to figure out the numbers. So we needed to multiply to negative 14, which means one of our factors is going to be a plus and the other one's a minus, because that's how you multiply to a negative. And it needs to add to negative 5. All right, our choices are 1 and 14 and 2 and 7. If we wanted to add to a negative 5, it's either going to be negative 2 plus 7 or negative 7 plus 2. It's going to be negative 7 plus 2. So we're going to put the 7 with the negative and the 2 with the positive. All right, because we need it to add to negative 5. You can always double check by foiling it out or multiplying it out. All right, so our last one, this is the one I want to spend a little more time on. This one is a pretty simple example because the numbers are so small, but it's a leading coefficient that's not 1. All right, so here's what I do. You do not have to do it this way. If you have a method that works for you, use it. All right, so here's what I do. I take the first number times the last number. That's my first step. And you could do the negative if you want. So negative 3. We do the same thing that we just did on the last two examples. So factors of 3 that add to negative 2. All right, so our only choices are 1 and 3. If it adds to a negative 2, it has to be negative 3, positive 1. Okay, so what I do with that is I rewrite my problem and I split the negative 2 into the negative 3 and the positive 1. If I have a negative and a positive, typically I will do the minus first, but I'm going to do the plus first just so I can show you factor by grouping with the minus there. All right, so then we factor by grouping. So we split that middle term into these two factors. All right, so now we factor by grouping. We take the first two terms and we factor out their GCF. Their GCF is x. And when we factor that out, we get 3x plus 1. Then we take the second two terms. This really has no GCF, but we have to factor out this negative. If it has no GCF, you're going to put a plus 1. In our case, we're going to put a minus 1 because it's negative. All right, anytime this term is negative, you have to factor out a negative at least. And I am going to put the 1 even though you could leave it off. So that makes this positive 3x and a positive 1 when you factor out the negative. Now notice these are the same. If they aren't the same, then you did something wrong. Either you picked the wrong numbers here or you factored out the GCFs wrong. But something is wrong. Or maybe it's not factorable. That could be a possibility too. So we factor out the 3x plus 1, and then once we get rid of that out of here, we get x minus 1. All right, so there's our proper factoring, and we could check it by multiplying it out. Like I said, you do not need to do it this way if you have a method that works for you. Also, when you multiply, sometimes these numbers get really big, so that's a disadvantage of this method, plus it's kind of long, but it works. All right, so if you don't know how to factor something with a leading coefficient that's not 1, try this method. All right.